Okay, today we're going to do something a little different. We're going inside an AQA GCSE Chemistry paper to really tear apart a question. Our goal isn't just about getting the right answer. It's about figuring out how to write the perfect answer, the kind that scores every single mark. And we're going to do that by looking at the examiner's own mark scheme.
So, here's the game plan. We're going to dissect question 7, which is all about making sulfuric acid. We'll look at every single part, from the chemical tests to the equilibrium stuff, and even the real-world compromises they have to make. By the end of this, you'll have a formula for turning what you know into maximum marks.
You know, question 7 is a fantastic example of a multi-part question. It really weaves together a bunch of different topics from the syllabus. You've got your practical chemical tests, you've got to interpret graphs, you need to understand equilibrium, and then you have to apply all of it to a real-world industrial process. So, let's get started.
First up, a classic practical skill. This is a 2-mark question that's all about testing for sulfate ions. And as you're about to see, when it comes to these questions, being precise with your language is absolutely everything.
Right, here's the question, word for word. Notice it's asking for 2 things. Describe the test and give the result. That's a massive clue right there. It's telling you that you need to give 2 separate pieces of information to get both of those marks.
So this is pretty much the gold standard answer. You state the chemical you add, and you state what you see. It's clean, it's precise, it's 2 marks. But what if you wrote something slightly different? What if you mentioned another chemical or maybe added an extra step? Would that still count? Let's check out what the official mark scheme says.
And this is where it gets really interesting. Look at that extra information column. It says you can allow barium nitrate solution, so that would also get you the mark. It also tells the examiner to ignore any mention of adding acid, so that wouldn't lose you a mark. But this last point is crucial. Mark point 2 is dependent on mark point 1. That means if you get the test wrong, you can't get the mark for the result, even if you correctly say a white precipitate is formed.
All right, let's move on to the second part. Here, we're shifting gears from recalling facts to analyzing data. This part is all about your ability to read a graph and connect what you're seeing to a really fundamental idea in chemistry.
First things first, let's just take a good look at this graph. On the bottom, the x-axis, you've got temperature going up, and on the side, the y-axis, you've got the percentage yield. So what's the story here? Well, if you follow the line, you can clearly see that as the temperature gets higher, the percentage yield gets lower. Just noticing that simple trend is your first step to nailing this question.
Okay, so you're given these 4 options. Your job is to connect the dots. You need to link the trend we just spotted in the graph, that lower temperatures give a higher yield, with the right scientific reason. Is the reaction exothermic or is it endothermic?
And there it is. That's the one. The mark scheme is looking for this exact connection. You've got the observation from the graph, the yield is smaller at higher temperatures, and you've got the scientific principle that explains it because the reaction is exothermic. Putting those 2 ideas together is the key.
And now we get right to the heart of equilibrium with Le Chatelier's principle. Basically, this principle just says that if you mess with a reversible reaction, the system will try to undo what you just did. This question isn't just asking what happens when you change the pressure, it wants you to explain why it happens.
To crack this one, we have to look really closely at the equation. The key, and I mean the key, is to count the number of moles of gas on each side. On the left, the reactant side, we've got 2 moles of sulfur dioxide plus 1 mole of oxygen, so that's 3 moles of gas in total. On the right, the product side, we have just 2 moles of sulfur trioxide.
See, this is a 2-mark question, and you need to make 2 distinct points to get them. For the first mark, you have to state that there are more moles of gas on the left. Simple as that. For the second mark, you have to explain the result. Because there are fewer moles on the right, increasing the pressure pushes the equilibrium to the right to counteract that change.
Okay, this next part is huge because it takes us out of the textbook and into the real world. In industrial chemistry, it's never just about getting the highest possible yield. You're always juggling things like cost, safety, and just how fast you can make stuff.
So you're probably thinking, okay, if higher pressure is so great for the yield, why not just crank it to the max? That's exactly what the exam asks. It wants you to come up with 2 practical reasons why a company might just stick with normal atmospheric pressure instead.
And look at this. The mark scheme gives you a whole menu of possible correct answers. Any two from this list would have bagged you the marks. You could talk about the yield being pretty good already, or you could talk about the cost of the energy needed. You could even bring up safety, like the risk of an explosion. I'll just leave this up for a moment so you can see all the different answers the examiner would accept.
And we're on to the final part of question 7. This one's a quick-fire knowledge check. We know there's a catalyst involved to speed up the reaction. The question is simple. What's the metal in that catalyst?
And the answer is vanadium. Specifically, in this industrial method, which is called the contact process, the catalyst they use is vanadium 5 oxide. That's just a key fact you need to know for this topic.
So, we've broken down that entire question. What's the big takeaway from all this? Well, it all boils down to one word: precision. It's about taking your correct scientific ideas and saying them with the exact language the examiners are looking for.
And this example just hits the point home perfectly. Let's go back to that question about pressure. You could write, using higher pressure costs more money. And you know what? You're not wrong. But now compare that to the answer from the mark scheme. Higher income from increased yield is outweighed by the extra expenditure. Can you see the difference? It's subtle, but it's everything. It shows you understand the economics of it, that the tiny bit of extra profit isn't worth the massive extra cost. That is a top-level answer.
And that's really the thought I want to leave you with. How can you take your answers to that next level of detail? Mastering the chemistry is half the battle, for sure, but mastering the language of the mark scheme, well, that's how you unlock every single mark. Thanks for joining me for this breakdown.